All right, let's deep dive into SWE-RL, Advancing LLM Reasoning via Reinforcement Learning on Open Software Evolution.
Okay.
This paper's causing a bit of a stir. And for good reason, It's the first time we're seeing reinforcement learning applied to real-world software engineering problems at this scale.
Yeah.
They're working with a massive data set of code changes and the whole context around them, from GitHub issues to developer discussions. The crazy thing is they found that training an LLM this way on all these messy real-world software engineering tasks actually boosts its reasoning skills in other areas like math and general code generation.
Yeah, it's a really clever approach that addresses a major gap in current LLM research.
Okay.
A lot of the impressive results we've seen so far have relied on either massive proprietary models or clever prompting tricks on simpler tasks.
Right.
SWE-RL takes a different route, teaching LLMs to reason through problems by immersing them in a full life cycle of real software projects.
So no more sanitized coding challenges or cherry-picked data sets.
Exactly. They're throwing the LLM into the deep end with 4.6 million GitHub repositories worth of data.
Wow.
And they're not just feeding it raw code changes either. They've painstakingly reconstructed the full context of each pull request.
Okay.
Issue descriptions, developable discussions, even the code before the changes were made.
So it sounds like they're really trying to simulate the experience of a human developer as closely as possible.
That's precisely it. They even want to step further and use another LLM to predict which files were relevant but unchanged in a pull request.
Oh, interesting.
This helps to combat the bias of models assuming every file needs modification, which isn't always the case in real-world scenarios.
Right. That's a neat trick.
Yeah.
Okay, so they've got this mountain of data. How do they actually use it to teach the LLM to reason like a software engineer?
Well, they use a reward function that's surprisingly simple but effective.
Okay.
If the LLM's output code isn't formatted correctly, it receives a negative reward. Otherwise, the reward is based on how closely its generated patch matches the actual patch from the pull request.
So they're training it to essentially mimic the solutions of experienced developers.
Precisely.
Yeah.
And by conditioning the model on the full file context, they're implicitly teaching it to both diagnose and repair problems. It has to pinpoint the fault location within the code before it can even attempt to generate a fix.
So that's starting to sound a lot like actual problem solving, not just pattern matching.
All right.
What kind of results did they see with this approach?
So they trained a 70 billion parameter Llama 3 model using SWE-RL.
Okay.
And the results are pretty impressive. It achieved a 41% success rate on SWE-bench Verified,
Okay.
which is a challenging benchmark that uses real-world GitHub issues hand-vetted by humans.
41% on real-world problems. That's significant, especially for an open source model of that size. How does that compare to the closed proprietary models?
It's on par with some of the best out there, including GPT-4.
Wow.
And that's not even the most surprising part.
Okay, now I'm really intrigued. What else did they find?
Well, while analyzing the model's performance, they observed what they call aha moments.
Aha moment.
Yeah. The LLM wasn't just blindly applying patterns, it was showing signs of genuine reasoning.
Okay.
There were instances where the model was reflecting on its own assumptions, exploring alternative approaches, and even employing divide and conquer strategies to break down complex problems.
Hold on. Are you saying that this model, trained solely on software engineering tasks, is starting to exhibit the kind of problem-solving abilities we associate with human intelligence?
It certainly seems that way. And these weren't pre-programmed behaviors either. They emerged organically from the model's interaction with the real-world data and the reinforcement learning environment.
That's pretty groundbreaking.
Yeah.
It suggests that the very act of grappling with these messy, real-world problems might be forcing the model to develop more generalizable reasoning skills.
Yeah, and here's where things get even more interesting. They tested the model on a variety of tasks outside of software engineering, including code generation in other languages, math problems, and general language understanding. The SWE-RL model consistently outperformed both the base Llama 3 model and a version fine-tuned with supervised learning. It seems that training on these specific, complex software engineering problems had a positive transfer effect, making the model better at a range of other tasks.
Wow, that's a powerful finding. It challenges the assumption that bigger models and more general data are the only paths to better reasoning.
Exactly. This suggests that the quality and specificity of the training data might be just as important, if not more so.
So what are the practical implications of this? I mean, we can't all be training LLMs on millions of GitHub repositories.
That's true, but the key takeaway here is the potential of domain-specific training. If we can identify other domains with this kind of rich, structured data,
Right.
we could potentially use similar techniques to create LLMs that excel in those areas.
LLMs that are less jack of all trades and more specialized experts. That's an intriguing thought.
Yeah.
And it's not just about performance. The emergence of these aha moments suggests that this approach could also lead to more transparent and explainable AI.
Yeah.
If we can understand how these models are reasoning, we can build more trust in their outputs and use them more effectively.
Absolutely.
Okay, I'm definitely sold on the potential of this. But before we get too carried away, let's take a closer look at some of the specifics. You mentioned they use an evaluation scaffold called Agentless Mini. Can you tell us a bit more about that?
Of course. So Agentless Mini is a streamlined version of a more complex scaffold called Agentless,
Okay.
which is commonly used to evaluate LLMs on SWE-bench. The key difference is that Agentless Mini simplifies certain steps, like code localization.
So they're stripping away some of the complexity to really isolate and assess the LLM's core repair abilities.
Exactly. This ensures that the impressive results they're seeing are truly a reflection of the LLM's improved reasoning, not just artifacts of the evaluation process.
That makes sense.
Yeah.
Now let's talk about the training process itself. They mentioned using GRPO, or Grouped Relative Policy Optimization. Why did they choose this particular algorithm?
Well, GRPO is a type of reinforcement learning algorithm that's particularly effective when you have multiple agents, in this case different instances of the LLM, learning simultaneously.
Okay.
It helps to stabilize the learning process and prevents individual agents from getting stuck in suboptimal solutions.
By comparing their performance to each other, the agents can more effectively explore the solution space and find the best approaches.
Precisely. And with a problem as complex as real-world software repair, there are often multiple valid solutions. GRPO allows the LLMs to discover this diversity and converge on the most effective strategies through collaborative learning.
So it's not just about finding any solution, it's about finding the best solution through exploration and collaboration.
Right.
That's a fascinating insight.
Yeah.
I'm really starting to see the potential here, but I'm also curious about the limitations of this approach.
Sure.
What are some of the potential downsides they discuss?
Well, one limitation they acknowledge is that the current reward function is based on comparing the textual similarity between the LLM's generated patch and the correct patch.
Which might not always capture the full complexity of what makes a good software solution. Two patches could look very different, but achieve the same functional outcome.
Exactly. And there's the risk that the LLM could become too focused on mimicking patterns in the training data rather than developing a deeper understanding of software design principles.
Right.
It might struggle to generalize to truly novel situations or come up with solutions that go beyond what it's seen before.
So there's a need for more sophisticated reward functions that go beyond simple textual similarity.
Absolutely. They need to capture things like code efficiency, elegance, and adherence to best practices.
Okay.
And another limitation is that the current evaluation is based on a pipeline approach, breaking the problem down into discrete steps. This might limit the LLM's ability to develop a more holistic understanding of the problem and explore more creative solutions.
So in the future, they might explore more open-ended evaluation methods that give the LLM more freedom to interact with the environment and learn through trial and error.
Precisely.
This has been a truly insightful deep dive so far. But before we wrap up this part of our discussion, I want to take a moment to summarize the key findings of this paper for our viewers.
Okay.
So if you're just joining us or want a quick recap, here's what you need to know. This paper introduces SWE-RL, a novel approach that uses reinforcement learning to train LLMs on a massive data set of real-world software evolution data. They've shown that this approach not only leads to impressive performance on challenging software repair tasks, but also boosts the model's reasoning abilities across other domains. They've observed these fascinating aha moments where the model exhibits signs of genuine reasoning and problem solving.
And the key takeaway is that the quality and specificity of the training data can be just as important as the size of the model. This opens up a whole new avenue for exploring domain-specific LLM development, where we can train models to excel in specific areas rather than trying to create one giant general-purpose AI.
Exactly. And while there are some limitations to the current approach, the findings are incredibly promising and suggest a bright future for LLM-powered software development and beyond. This idea of domain-specific training is really intriguing. It kind of challenges the current trend of building ever larger, more general-purpose language models.
Right.
I'm curious to hear where you think this research is leading.
Well, I think it opens up a whole new frontier in LLM development.
Okay.
Imagine a future where we have specialized LLMs for every field.
Yeah.
Medicine, law, finance, even creative writing. Each one trained on a massive data set of domain-specific data, able to reason and problem solve at a level we haven't seen before.
That's an exciting vision.
Yeah.
It's like having a team of expert consultants,
Right.
each with deep knowledge in their respective fields, ready to assist us with complex tasks.
Exactly. And just like a well-functioning team, these specialized LLMs could collaborate, sharing insights and leveraging their unique strengths to tackle even more complex challenges.
Yeah, it's a move away from the idea of one monolithic, all-knowing AI
Right.
and towards a more distributed, collaborative approach.
Right. And I think it aligns more closely with how human intelligence actually works.
Okay.
We don't have one giant brain that does everything. We have specialized areas of the brain that work together, communicating and sharing information to solve problems.
So this research could be a stepping stone to building AI systems that are not only more powerful,
Yeah,
but also more aligned with how humans think and work.
absolutely. And I think that's a crucial aspect to consider as we continue to develop increasingly sophisticated AI systems.
Okay, now before we get too lost in the future,
Sure.
let's circle back to some of the technical details of SWE-RL. We've talked about the data, the reward function, and the evaluation method. But I'm curious about the actual training process. What were some of the challenges they faced in training a model on such a massive data set?
So one of the biggest challenges with reinforcement learning is that it can be very sample inefficient.
Okay.
It often requires a huge amount of data and a lot of computation to train the model to a satisfactory level.
Yeah.
And when you're dealing with a data set as large and complex as the one used in SWE-RL, those challenges are just amplified.
So how do they address those challenges?
Well, they used a number of techniques to optimize the training process.
Yep.
One key technique was the use of GRPO, which we discussed earlier. This algorithm is particularly well suited for handling large-scale reinforcement learning problems with multiple agents.
Right, because it encourages collaboration and exploration,
Exactly.
helping the agents to more efficiently find optimal solutions.
Were there any other techniques they used to make the training more manageable?
Yeah, they also employed a technique called curriculum learning.
Where the model is gradually exposed to increasingly difficult tasks.
Right.
This helps to prevent the model from getting overwhelmed and makes the learning process more efficient.
That's a common technique in human education as well.
Yeah.
You don't start with advanced calculus, you build up to it gradually.
Exactly. And they also used a technique called distributed training,
Okay.
where the training process is spread across multiple computing devices. This allows them to leverage the power of parallel processing to speed up the training.
So they're essentially throwing a lot of computational horsepower at the problem, but also using clever algorithms and techniques to make the learning process more efficient and effective.
Precisely. It's a combination of brute force and strategic optimization.
Now, while this research is clearly a step forward,
Yeah.
I'm curious about what you see as the next big hurdle in this area. What are the remaining challenges that need to be addressed to further improve LLM-powered software development?
So one of the biggest remaining challenges is developing more robust and generalizable reward functions. As we discussed earlier, the current approach of relying on textual similarity has limitations.
Right.
We need reward functions that can capture the nuances of what makes a truly good software solution, taking into account factors like efficiency, readability, and maintainability.
So we need to move beyond simply mimicking existing code
Right.
and towards a deeper understanding of software engineering principles and best practices.
Exactly. And another challenge is developing more open-ended evaluation methods that allow LLMs to demonstrate their full capabilities.
Okay.
The current pipeline-based approach is helpful for isolating specific skills,
Yeah.
but it might be limiting the model's ability to engage in more creative problem solving and explore truly novel solutions.
It sounds like the next step is to create environments where LLMs can experiment more freely, learn through trial and error,
Right.
and perhaps even collaborate with human developers to find the best solutions.
That's right. We need to move beyond treating LLMs as simply code generators and start thinking of them as partners in the software development process.
And that requires a fundamental shift in how we design and evaluate these systems.
Absolutely. It's about moving away from purely quantitative metrics and towards a more qualitative assessment of the LLM's understanding of the problem domain and its ability to contribute meaningfully to the development process.
Now, shifting gears a bit.
Okay.
I want to touch on a topic that's often raised when we talk about AI and software development, the potential impact on human jobs.
Yeah.
Some people worry that LLMs like this will eventually replace software engineers. What are your thoughts on that?
I think it's important to remember that LLMs are tools.
Okay.
And like any tool, they can be used for good or ill. It's up to us as developers and researchers to ensure that these tools are used in a way that benefits society as a whole.
So rather than seeing LLMs as a threat, we should view them as an opportunity to augment human capabilities and create new possibilities.
Exactly. LLMs can automate tedious and repetitive tasks, freeing up human developers to focus on more creative and high-level aspects of software development. They can also provide valuable insights and suggestions, helping us to write better code and build better software.
It's like having a superpowered assistant
Right.
that can handle the grunt work and help us to see problems from new perspectives.
Precisely. And as these models continue to improve, I believe they will become increasingly valuable partners in the software development process.
So instead of fearing obsolescence,
Yeah.
we should embrace the opportunity to collaborate with these powerful tools and leverage their strengths to build even more amazing things.
Absolutely. The future of software development is not about humans versus machines. It's about humans and machines working together to create something truly extraordinary.
This has been a fascinating discussion.
Yeah.
And I feel like we've only scratched the surface of what's possible with LLM-powered software development.
Right.
But before we move on to our final thoughts, I want to make sure we've addressed all the key technical aspects of SWE-RL. Is there anything we've missed?
I think we've covered the most important points. We've discussed the data, the reward function, the training process, the evaluation method, and the limitations of the current approach.
Great. Then let's move on to our closing thoughts and discuss what all of this means for the future of AI and software development. Okay, so we've really dug into the technical details of SWE-RL.
Yeah.
But what does this all mean for the future of AI and software development? It feels like we're at a real turning point.
I agree. This paper has really thrown down the gauntlet, challenges our assumptions about how we should train LLMs and what they're actually capable of.
We've been so focused on just scaling up models and giving them more and more general data.
Right.
But SWE-RL shows that specialization can be such a powerful way to get better reasoning and performance.
Right. It's like the old saying, jack of all trades, master of none. Maybe instead of trying to build one giant AI that can do everything, we should be focusing on developing a diverse ecosystem of specialized LLMs, each a master in its own domain.
That's kind of like having a team of expert consultants at your fingertips.
Exactly.
Each with deep knowledge and expertise in a specific area.
Exactly. And these specialized LLMs could even collaborate with each other,
Right.
sharing knowledge and insights to solve complex problems that require interdisciplinary expertise.
Yeah. It's an exciting vision for the future of AI.
Yeah.
A future where AI augments human capabilities rather than replacing them.
And I think SWE-RL gives us a glimpse of how we might actually get there.
Yeah.
By carefully curating training data and focusing on specific domains, we can develop LLMs that are not only powerful, but also more transparent, explainable, and trustworthy.
Which is so crucial if we want these systems to be widely adopted and integrated into our workflows.
Absolutely.
No one wants to rely on a black box, especially when it comes to something as critical as software development.
Absolutely. Trust and transparency are essential for any AI system that's going to work alongside humans.
Okay, so what are the next steps? What needs to happen to turn this vision of specialized collaborative AI into a reality?
Oh, for one thing, we need to continue to develop and refine the techniques that were pioneered in SWE-RL.
Okay.
This includes exploring even more sophisticated reward functions that go beyond just textual similarity and actually capture the true essence of good software design.
Right, so we need to move beyond just mimicking existing code
Right.
and towards a deeper understanding of software engineering principles and best practices.
Exactly. We also need to create more open-ended evaluation environments
Yeah.
that allow LLMs to demonstrate their full range of capabilities and encourage more creative problem solving.
And maybe most importantly, we need to foster a culture of collaboration
Yeah.
between AI researchers, software developers, and domain experts. The future of AI-powered software development depends on bringing together the best minds from all of these disciplines.
Yeah, I think that's a great point.
It's an exciting time to be working in this field.
Yeah, it is.
We're really at the cusp of something truly transformative.
I couldn't agree more. The potential for AI to revolutionize software development and many other industries is immense.
Yeah.
And papers like SWE-RL are paving the way towards a future where AI is not just a tool, but a true partner in innovation.
Well, this has been an incredible deep dive into SWE-RL.
It has.
I'm feeling inspired, a little bit mind blown,
Yeah.
and definitely ready to see what the future holds for this exciting field.
Me too. It's a good reminder that there's always more to learn, more to explore,
Yeah.
and that the boundaries of what's possible are constantly being pushed.
And that's what makes this field so fascinating.
Yeah.
Thanks for joining me on this deep dive. Until next time, keep exploring, keep learning, and keep pushing the boundaries.
Absolutely. Thanks for having me.